Link back. Oh, link back. Okay, thank you. Yeah. Dah. This slide. Assalamualaikum and a very good morning to all my students. Today we will continue with the new topics, that is engineering mechanics. So we start with subtitle 2.1, three-dimensional force system, 3D. So today we will discuss about topic A, define vector using Cartesian coordinate system. Okay, introduction. Cartesian coordinate system. Simple vector quantities can be expressed geometrically. As the application become more complex or involve 3D, express vector in Cartesian coordinate x, y, and z is needed. So at school, you learn about only two axes. Now in matriculation, we learn about three axes. So basic vector problems using Cartesian coordinate system. Cartesian vector, position vector, dot product, and cross product. Introduction. A coordinate system that specifies each point uniquely in a plane by a set of numerical coordinates, which are the sign distance to the point from perpendicular direction lines, measured in the same unit of length. Sets or arrowhead of this vector are defined by a plus or minus sign, depending on pointing toward the positive or negative axis. This is the concept of we are using a right-hand coordinate system. That means usually thumb of the right hand point in the direction of z-axis. Here is the z-axis. The axis will point outward. When the right hand finger have curl above this axis, directed from the positive, directed of the z-axis, when the right hand finger are curled above this axis and directed from the positive x toward the positive y-axis. So that means you can see, but sometimes they may change. Sometimes this is z-axis, y-axis, and z-axis. This is not fixed, but usually the z-axis pointed upward, and to the left is x-axis and y-axis. So if the coordinate here negative, we follow. If the coordinate here is x is positive. If coordinate here y is positive, if coordinate here y is negative. If the coordinate below upward of z-axis is negative, upward is positive. So unit vector. Unit vector have a magnitude and a direction. Vector have a magnitude and direction. So and are labeled with an arrow. This is arrow. Usually, example A. You can see if they have a arrow above the A alphabet, we can define it as a vector. A unit vector is a vector that has a magnitude of 1. Usually, a unit vector has a magnitude of 1. Example, vector V. This is the coordinate 1, 3. It's not a unit vector because its magnitude is not equal to 1. 1 squared plus 3 squared. 1 squared is 1 plus 3 squared is 9. 10 square root of 10 is not equal to 1. Okay. Unit vector. Any vector can become a unit vector by dividing it by the magnitude of the given vector. So a unit vector is represented by the symbol of here, which is called a cap or head, such as A, and it is given by A head equal to A divided by magnitude of A, where A is a for norm and magnitude of vector A. Any vector can become a unit vector by dividing it by the vector magnitude. Okay. For example, vectors are often written in the x, y, z coordinate. This is v equal to x, y, z, or v equal to xi plus yj plus zk. So the magnitude of vector is v vector equal to square root of x, this x, plus y squared plus z squared square root. So unit vector equal to vector divided by magnitude of vector. In bracket form, we can write it here. Right? Vector equal to v vector equal to magnitude of v, x, y, z divided by square root of x squared plus y squared plus z squared. So you can see this. X divided by x squared, this is the magnitude of vector. This is vector. Y divided by magnitude of vector. Z divided by magnitude of vector. So this is the same equation, but you can see this is x divided by this is I, this is j coordinate, this is k coordinate. So example of the unit vector is like this. Find the unit vector P for the given. This is the coordinate 12i minus 3j minus 4k. Show in the both the format bracket and unit vector. Let's find the magnitude of the given. So how we want to find this magnitude? We must square root of x squared plus y squared plus z squared. So we can find the magnitude of this coordinate. So the magnitude is the magnitude of this is 12 squared is 144, 3 squared is 9, 4 squared is 16. If they have negative, if you square negative, it become positive. Square root of it you can get the square root of 169. That means 13. So we can so how we want to convert it to the coordinate. This is vector. We want to convert it to the coordinate. Okay, see. So the unit vector p equal to p magnitude of p. P vector equal to, so we can find it. This one is the 12i minus 3j minus 4j divided by 13. 13 is the magnitude of p, vector p. So you can find it. So this one, 12 over 13 minus 3 over 13 minus 4 over 13. Okay. So the unit vector of the bracket form is, the unit vector of this is 12 over 13, negative 3 over 13, negative 4 over 13. So we are converting this to the coordinate. Okay. Next question. Find the vector q for the given. Okay, you can see here the vector. This is a vector. So in both format, bracket and unit vector. Let's find the magnitude. So as usual, we must find the magnitude of this q. The magnitude is 2 squared minus 2 squared. That means 4. 4 squared 16. Negative 4 squared 16. So we get 36. The magnitude of q is 6. So how we want to find the unit vector of this unit vector? We must vector of each axis divided by the vector of the magnitude of the vector. Okay, vector of each axis I divided by magnitude of the vector. So you can get this. So q divided by magnitude of q. That means you can see xi, this is a coordinate of a given vector, divided by magnitude of the vector. Magnitude of the vector is summation or is square root of x squared plus y squared plus z squared square root. So we can see this. Okay, negative 2 divided 6. If in this equation, you must don't forget about the sign, negative or positive. Okay, you can see this, negative 2 divided by 6, 4 divided by 6, minus 4 divided by 6. So you can get it. This is the unit vector. So the unit vector is this. You can see this. Okay. Okay. I hope you understand my explanation. If you have any question regarding this topic, please send to the comment. And to all the mechanical students, don't forget to fill the form, the attendance form that I given you through the mechanical channel. That's all for today. Thank you very much for watching this YouTube. Bye-bye.